Hi. So last lesson we looked at how atoms form ions and we looked at the electronic configuration of different atoms. Today's lesson we're going to look at how when drawing dot and cross diagrams, how we can use these to help us show the ionic bonding between two oppositely charged atoms. So just a recap of what an ion is an atom or a molecule with a charge due to it either gaining or losing electrons. So when we lose an electron from an atom, we gain a positive charge, and that ion becomes known as a cation. And the easiest way we remembered this last time was that cats make us feel happy, and a positive charge is a good thing. So we form cations. Anions are when we gain an electron, so when an atom gains an electron, we form a negative charge. So the other easier way we used to remember this was that anions are like onions. So onions and anions sound the same and they make us cry, so it kind of gives us the negative feeling. So that's where we get our negative charge from. The next key point was that these opposite charged atoms can then form an ionic bond. So they are attracted to one another, so a plus charge will be attracted to a negative charge, and because they attract to one another, they will form an ionic bond. So in today's lesson, we're going to see how we can draw the dot and cross diagrams to show the ionic bonding between different ionic compounds. So for example, sodium chloride. So sodium, if we look at our periodic table here, sodium is in group 1. This means that sodium will have 1 electron on its outer shell. So when we're drawing ionic bonds, we remember that it's the electrons on the outer shell that take part. We're also dealing with 1 chlorine atom, so we have 1 sodium and 1 chlorine atom. If we look at our periodic table here, chlorine is in group 7 of the periodic table. So that means chlorine would have 7 electrons on its outer shell. So we draw chlorine here. And we're going to draw the electrons in a cross format instead. And I'll explain why this is important afterwards. So that's 6 electrons, and then we have our 7th here. Okay? So in order for an ionic bond to form, sodium, for it to become stable, will lose that electron. So when we draw this out, sodium has lost that electron, so its shell will be empty. And once we've drawn that structure, we draw brackets around it to show that this is the final ionic atom. And we place a plus charge. So why do we place a plus charge? How many electrons have been lost? Yeah, that's right. So we've only lost 1 electron, so that's why we only just put the plus charge. So with chlorine, chlorine can accept this electron that sodium has given off. Okay, so when we draw chlorine out, we draw it in its original form. So we draw all its electrons. So that would be 3, 4, 5, and 6. And then we have the 7th one here. Because it can accept this electron, we are drawing sodium's electron as a circle. So if we see our structure now here, it makes sense why we use dots and cross, to show that this electron is the electron that has been transferred to chlorine. So it's been transferred from sodium to chlorine. And we then draw our brackets around the structure to show that it's finished. And we place a negative charge because we've only gained 1 electron. So this is for sodium chloride. We're now going to look at magnesium oxide. So let's just rub this out quickly. So if we look at magnesium oxide, again we're only dealing with 1 magnesium atom, and we're dealing with 1 oxygen atom, so it's 1 of each. So magnesium here, draw a circle around. Now, could you tell me where magnesium is in the periodic table? So if we're looking at our periodic table here, Where is magnesium? That's right, it's in group 2. So how many electrons would magnesium have on its outer shell? Correct, yeah, that's 2 electrons on its outer shell. So let's draw the electrons as crosses for now. Maybe we could draw it in a different color. So we'll draw the electrons in red. So magnesium has 2 electrons it can share, okay? We're dealing with one oxygen atom, and can you tell me where oxygen is in the periodic table? Not quite, not in group 5. Let's have another look. Yep, it's in group 6. So what would that mean then? Well done. So it means that we are dealing with 6 electrons for oxygen. So we draw a ring around oxygen, and we're going to draw those 6 electrons in a different color. So we'll draw them as dots for oxygen. So 1, 2, 3, 4, 5, and 6 here. Okay. So in order for magnesium to be stable, it will be easier for it to lose these 2 electrons. So when we draw our structure, magnesium will have no electrons, in its shell. We will draw the brackets around to indicate that this is the final form. And then ignore this line. So then what we do is we put a 2 plus charge. And the reason why we put a 2 plus charge now is because magnesium has lost 2 electrons. If we go to oxygen, oxygen can accept 1 electron here, and it can accept 1 electron here. So when we draw oxygen out, we draw first its own electrons. So 1, 2, 3, 4, 5, and 6. And then to show that we have gotten those electrons from magnesium, one will be placed here, the other will be placed here. Okay? Then we draw our brackets around our structure. And because oxygen has gained 2 electrons, we get a 2 minus charge. Now the key thing to remember here is that our charges should always cancel out to give us 0. So we've got 2 plus here, 2 minus here, they cancel out one another to give us 0. So it's important that we remember that whenever we are drawing these ionic structures, that our charges always cancel out one another. So we're going through a bit more difficult example now. So we're going to focus on, calcium fluoride. So here we're only dealing with 1 calcium atom, but 2 fluorine atoms. So when we draw this out, we draw 1 calcium, and which group is calcium in? Could you tell me? It's somewhere here. Yeah, well done. It's again group 2. So we're just going to draw 2 electrons for calcium on its outer shell. However, because we're dealing with 2 fluorine atoms, we need to draw 2 fluorine atoms separately. So we have 1 fluorine atom here, we have another fluorine atom here. So your circles should be proper circles, not these oval shapes, okay? So we're going to now draw fluorine's electrons in. So we draw 1, 2, 3, 4, 5, 6, and 7. It's 7 because fluorine is in group 7, so there are 7 electrons on its outer shell. 1, 2, 3, 4, 5, 6, and 7. So each fluorine atom can accept 1 of those electrons. So when we draw this out, calcium will lose 2 electrons to become stable. So calcium will have no electrons in its rings. We draw those brackets around. We draw those brackets around, and we do 2 plus to indicate that calcium has lost 2 electrons. The next thing we can do is then we can add in our fluorine atoms. So we're going to do fluorine. Fluorine would have gained, so it would have had its original electrons here, so 7 of its original electrons. And because it's gained 1 electron from our calcium, we draw that as an X. And then we finish off the structure and we place a minus charge because fluorine has only gained 1 electron. You draw this the same for the second fluorine atom. So we have a fluorine atom here. This fluorine has gained an electron to also fit here. So again, drawing those electrons, so 1, 2, 3, 4, 5, 6, and 7. And then we're drawing in our last electron. And because it's only gained 1 electron, it's still a minus charge, okay? So we said that the charges should cancel out one another, and that is the case here. We have 2 plus, but when we add these individual negative charges together, we still get 2 minus. And as a result, these charges cancel out, and we get a 0 charge overall. So the last example is aluminium chloride. So I will give you a hint. So I want you to do this on your own. However, I will draw out the first part. So aluminium, and we have 3 chlorine atoms this time. So we're dealing with 1 aluminium and 3 chlorine atoms. So for aluminium, you would draw 3 electrons on its outer shell. So 1, 2, and 3. And because chlorine is in group 7, it will have 7 electrons on its outer shell. So 1, 2, 3, 4, 5, 6, and 7. Oops. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. Now, I want you to draw me out in this space here. Ooh, maybe it's not enough space. So I want you to draw me in this space here how many electrons aluminium will lose, the charge it will have, and its structure. And I want you to draw me the electronic configuration structures for chlorine once they have gained each electron from aluminium. So just how I've been showing you in the first 3 examples, I want you to show me now for aluminium chloride. And I want you to show me what the overall positive charges are and what the overall negative charges are, and if we do get 0 overall. So I'll give you, let's say 8 minutes, not 8 minutes, let's say just 5 minutes drawing out these structures. So off you go. Alright, that's the end of this presentation.